Hey guys, it's Mr. C, and in this video we're going to look at solving systems by substitution. And we already have some videos on this, but this is going to be another one with some extra problems in it, so you guys we'll just have some extra things to look at. And so there's several different systems of equations we're going to look at. This one right here, the system, both equations are in slope-intercept form. When this happens by substitution, if y is equal to this and then y is also equal to this, that means that these two right-hand sides are actually equal to each other by substitution. And then what we do is we set these two right-hand sides equal to each other and we solve for x, because we want one equation with one variable in it, not two. So what we're going to do is first we're going to set 2x minus 1 equal to x plus 1. And we're going to solve that equation with variables on both sides. So what I would do is subtract x. And we've done enough of these, so you can do it whatever way you want. X minus 1 is equal to 1. Add 1 to both sides. I'm thinking ahead. Okay, those cancel. And x is equal to 2. So I was thinking and I wrote it. So x is equal to 2. So wherever these two lines meet, we have no idea, but we do know the coordinate of where they meet is, the x coordinate is 2. So to get the y coordinate, what you do is you take this value for x and you plug it back into one of the equations for x. So if x is 2, then 2 plus 1 is 3, and that's my y value. And you could have plugged it in up here also, and it will still give you 3. 2 times 2 is 4, take away 1 is still 3. So 2 comma 3 is the solution. All right, here's example number 2, second one. Again, we have two equations in slope-intercept form, and so we're going to set the right-hand sides equal to each other, like we just did, and see what happens. I might go ahead and add 2x to both sides. 3 is equal to 3x minus 3. Add 3 to both sides. So 6 is equal to 3x. Divide by 3. And we get 2 is equal to x. I guess again, because it was 2 last time. So let's take a look now. We know that wherever they meet, the x coordinate is 2. Plug that 2 back in for an x up here. 2 take away 3 is negative 1. And so your y coordinate is negative 1. Okay, so now we have a couple equations, and these two equations are not in slope-intercept form. So if you want to use substitution, you have to have one of these, at least one of these coefficients, 3, 1, negative 2, negative 6. At least one of these has to be a 1 or a negative 1. So we have a 1x right here. So what we're going to do is we're going to take this equation and solve it for x, which means we're going to take the negative 6y and move it to the other side. If you do that, you're going to get x is equal to negative 7. And then if you move the negative 6y to the other side, it would be a positive 6y. So here's what's going on now. Now, x is equal to negative 7 plus 6y. If that is true, we're going to take that expression and plug it into the other equation for x. And we call this cut and paste. It's our cut and paste property. So we're going to cut the x out up here and paste in what it equals. Looks kind of weird, but here's what's going to happen now. When you plug in this for that x, you're now going to get 3 times, not x anymore, but negative 7 plus 6y equals, or I'm sorry, minus 2y, still got that, equals 11. So now we have one equation with one variable, and that variable is y. So if we distribute here, we get negative 21 plus 18y minus 2y equals 11. Okay, keep going. So negative 21, 18y minus 2y is a plus 16y equals 11. Add 21 to both sides. And we get 16y equals 32. And so if you divide by 16 on both sides, we see that y is going to be equal to 2. So your y value is 2 for wherever these two lines meet. We can write it like this. So we got the y this time. Now, if y is 2, we're going to take that y value and plug it in either here, or we can even plug it in for that y right there, which may actually be easier. And when you plug in that y value, you're now going to get your x coordinate. So the x coordinate is -7 plus 6 times 2. So -7 plus 12, and that's going to turn out to be a positive 5. So that means my x value, x coordinate of the ordered pair where they meet is 5. So 5, 2. So you can either write your answer as an ordered pair, or you can box in the x and y values. Okay, next example. Okay, again, if you want to use substitution, at least one of these coefficients has to be a 1, and we do have a 1y right there. So what I'm going to do is I'm going to move the 2x over, and we get y is equal to -2x minus 3. Or you could write -3 minus 2x. Either way, it doesn't matter. So if that's what y is, then we're going to take this expression and we're going to plug it in all the way up here for that y right there, and then we're going to solve. And these problems are all over the place, so it's kind of hard to keep this stuff just kind of boxed in one little place. It kind of spread all over the paper. So this time what I'm going to do is I'm going to say 6x minus 3 times, not y, but -2x minus 3 equals -15. Now I have one equation with one variable, and that variable this time is x. So here's what I'm trying to find, x and y, and it looks like I'm going to get the x first. So here we go. Distribute 6x plus 6x, because that's what -3 times -2x is, plus 9 equals -15. Okay, so we're going to get now 6x and 6x is 12x plus 9 equals -15. Subtract 9. So 12x is equal to -24, which is good. Divide by 12. And x is equal to -2. So now we know that the x coordinate is -2. So we're going to plug that back in for that x right here. And we're going to find the y value. So then y is equal to -2 times -2 is positive 4 minus 3, which means y is equal to 1. And so there's our y coordinate. X is -2, y is 1. All right, next example. Okay, this time we have a 1y right here. So this time we're going to take this equation and we're going to solve for y, which means we're going to move the -2x to the other side, and we're going to make it y is equal to positive 2x on the other side minus 11. Well, that's what y equals. So we're going to take this expression now and plug it into the other one for y by substitution. And we call this cut and paste. You cut the y out and paste in what it equals. And now we have x plus 9 times, not y anymore, but 2x minus 11 equals 15. And we solve that equation for x. Distribute first. So x plus 9 times 2 is 18x minus 99 is equal to 15. So now we're going to get 18 and 1 make 19x. And we're going to say minus 99 is equal to 15. Add 99 to both sides. So 19x is equal to 114. So now take 114, divide by 19, and we get 6. So x is equal to 6. So here's our ordered pair. We now know that x is 6. So now what do? We take that 6 and we plug it back in up there for the x to get our y value. So y is equal to 6 times 2 is 12. 12 minus 11 is 1. So y is 1. All right, here's our next example. Okay, this time we have some choices here. This time we have negative 5x plus y is equal to 19 and x minus 7y is equal to 3. So we could either solve this equation for y or we could solve this equation down here for x. So what I'm going to choose to do, just for fun, is I'm going to solve this bottom equation for x, which means I'm going to add 7y to both sides. So now we get the new equation, x equals 3 plus 7y. Okay, that now is going to get plugged in to the other equation for x, because that's what x equals, right there. So all the way around is where that's going. So now we have negative 5 times, not x anymore, but 3 plus 7y plus another y equals 19. So now we have one equation with one unknown, and that's y. So here we go. Distribute, usually the same thing every time, negative 15. 7 times 5 is 35, y, plus another y is equal to 19. Negative 35 and 1 make negative 34. Let's see, add 15. So negative 34y is equal to 34 divided by negative 34, and y equals negative 1. So wherever these two lines meet, the y coordinate is negative 1. And so what do we do now? We plug that negative 1 back in up here for y and get the other value, the x value. So x is 3 plus 7 times negative 1. That's really negative 7. So 3 minus 7, negative 4. So x is negative 4. All right, a couple more examples. This one you already have y solved for 3 over 2x minus 3. So this time what we're going to do is we're going to take this and we're going to plug it into the other equation for y by substitution and then see what happens. Okay, so if we do that, we are now going to get 3x minus 2 times, not y, but 3 over 2x minus 3 equals 6. All right, so we now have, we have to distribute, right? We have 3x, negative 2 times 3 over 2x is really going to be a negative 3x. Negative 2 times negative 3 is positive 6. So plus 6 is equal to 6. 3x minus 3x is 0. So we wind up with 6 is equal to 6, which is a true statement. So the variables canceled and left a true statement. So what that means is these two lines are actually the same line. And so since the two lines are the same, the variables canceled, the variable canceled, and it left a true statement. So your final answer for this one, since both lines are the same, is going to be infinitely many solutions. And so that does happen from time to time. Okay, next example. This time we have x minus y is equal to 1 and 4x minus 4y is equal to 2. So we'll take this top equation and I'm going to solve for x, which means I'm going to move the negative y to the other side. So x is equal to 1 plus y. All right, so now I'm going to take this for x and substitute it into the other equation for x. And let's see what happens. So now we get 4 times, not x, but 1 plus y, minus 4 times y. equals 2. And distribute. So 4 plus 4y minus 4y equals 2. Well, the 4y and negative 4y cancel out, and we get 4 equals 2, since those canceled out. That is a false statement. So if the variables cancel and it leaves a false statement, that means the two lines have the same slope, but different y-intercepts. And so they are parallel lines. Parallel lines. Now that is not our answer. That's just a description of the lines over here. Our answer is no solution, because two parallel lines or pair of parallel lines will never meet. And so we're looking for the place where they meet. Well, they don't meet. And so it's going to be no solution. Okay, so here's another one. This time, we're going to use substitution again. Let's change markers here. All right, let's go ahead and take y equals x minus 4. And we're going to take that and plug it in for y down here. And here's what we're going to get. 4x plus, not y anymore, but x minus 4. And you can use parentheses if you want to. They're not really going to hurt you here because there's nothing in front of the y. X minus 4 equals 26. And we solve. 4x and another one make 5, I'm sorry, 5x. So we got 5x minus 4 equals 26. Add 4 to both sides. So 5x is equal to 30. Divide by 5. And we get x is equal to 6. So wherever those two lines meet, the x coordinate is definitely 6. If we take that 6 and plug it back in, x right here, 6 take away 4 is 2, and that means that they meet at 6, 2. All right, next example. This time we already have x solved. X is equal to y plus 4, and so we're going to take all of this and replace that x down there with y plus 4. And so here we have 2y plus, not x anymore, but y plus 4 equals 19. Again, I don't have to use parentheses because it was just a 1x I'm plugging it in for. So 2y and another one make 3. Subtract 4. 3y is equal to 15. Divide by 3. And we get y is equal to 5. So wherever these two lines meet, the y coordinate is 5. Again, we take that 5, plug it in for y right there. And we have 5 plus 4 is 9. So they're going to meet at 9, 5. All right. A couple more, it looks like. Okay, this example, a couple choices we could make. I'm going to go ahead and take the top equation and solve for, well, actually, you know what? Let's take the bottom equation and solve for this y. So we're going to move the 4x to the other side. So if we move the 4x to the other side, we'll have y is equal to 20 and then minus 4x on the other side. Okay, so now we're going to take all of that for y here and plug that into our top equation for y. Now we do have a minus in front of the y, so we need to be careful. So 2x minus, now I do have to use parentheses because there's a minus there. 20 minus 4x equals negative 2. And now we're going to distribute our negative. So 2x minus 20 plus 4x equals negative 2. 2x and 4x make 6x. Minus 20 is equal to negative 2. Add 20. 6x is equal to 18. divide by 6. And it looks like x is equal to 3. So wherever these two lines meet, the x coordinate is 3. Well, if x is 3, y then is going to be 20 minus 4 times 3, or 12. And 20 take away 12 is 8. And so the y coordinate is 8. Okay, our last example, a couple choices. This one, you can either solve for x or solve for y. You got y here, you can solve for y down here. So you got 3 different choices you can make. I'm going to make a decision and solve the top one for x. X equals 4, and then if you move the y to the other side, instead of being plus, it would be minus y. Okay, by substitution, we now take all of this for x, and we plug it in for the x in the other equation right there. All right, so 4 times, not x anymore, but 4 minus y, because that's what x equals, plus another y equals 1, and we just have to solve this equation. Distribute. 4 times 4 is 16. 4 times negative y is negative 4y. Plus y is equal to 1. 16, negative 4y and 1 make negative 3y. Subtract 16. Negative 3y is equal to negative 15. Divide by negative 3. And we got y is equal to, what's that going to be, 5? Positive 5. So wherever these two lines meet, the y coordinate is 5. Okay, we're going to take that 5 and plug it in for that y right there. So x equals, this time, 4 take away 5. And so that's going to be a negative 1. And that's your x coordinate. May have to watch this video a couple times just to get used to this, solving by substitution, because these problems are a little bit more challenging. There's lots of steps, and they're kind of all over the place. But if you practice it enough, you can get it. So remember to like my video and subscribe to my channel if you haven't already. And we'll see you guys later. Bye.